Bismillah. Right, here we go, people. Good morning, class. At this point, we're looking at graphs. You guys had some homework, correct? Right. What was Oh yes, no, the day before yesterday. So there's homework I must mark, in other words. Yes. Okay, so I'm going to take a copy of this. It was number 5, 6, 7, 8, 9 to 10. Eh? Right, let's go. Listen, why are you making so much? Okay, relax. Just relax. Just hang on. We just see how far we got. I probably didn't save it. Let me just check quickly. So if I look at where we stopped, now why do I have 6 to 10 on the board?
So it was 6 to 10 and then 11.
Yeah, now you just had to let me do 6 to 10. When I go down, I would realize, hey, I gave you this as well. But now you people are making a noise and all unnecessary. But you were excited that you did the homework. And now you want me to mark all of it. Yes.
The homework is from 14 to 18.
Girlfriend, we already know what the homework is. So I didn't give you 5 to 10. Okay, then I'm real confused. Okay, let's just go up here. Okay, so yesterday, the last lesson, we completed example on page 70, number 3. That was the last thing I did. Okay. So if I look at that, oh, is that what you're trying to tell me? That I'm confused? Okay, nice. No, you're right. And I think you just want to make a noise. Right, so we did example 1, 2, 3, 4. Is that correct? Did we do 5? No. So we did do 4. Do 3. So I must do 4. 5. 6. Alright, so what I'm going to do is, I'm going to first do the examples finish. Okay? So let's do the examples finish first, and then with the time that's left, we're going to mark whatever there was for homework. Is that okay? Alright, let's start there. Yes? Yes, you may. This was on page 70. Page 70. Don't forget, bring money on Monday. Tax. Yeah, we're happy, no? It's fine, listen. It's fine. Shh. Right. The question is, find the equation of the line parallel to. People, if lines are parallel, what do we know?
Equal.
Gradients are equal. Not so. So write the sum down. Find the equation of the line parallel to y is equal to 2x plus 3 with a y-intercept of minus 5. Okay, we're going to do that on the board now. Right, the question says find the equation of the line parallel to y is equal to 2x plus 3 with a y-intercept of negative 5. Too fast. Going too fast. Right. So people, if the lines are parallel, we say that the gradients are equal. So if these are the two lines, the one line is equation is y is equal to 2x plus 3, and the other one is going to be y is equal to, but what we know, what's the same? The gradients. Gradient 1 is equal to gradient 2. The line 1 is gradient is equal to the line 2's gradient. Not so? Okay. So what is line 1's gradient? 2. So the gradient of the second line is also 2. Not so? So what do I say? The equation of the straight line will be in the form of y is equal to mx plus c. What is m? 2. X and c is normally your y-intercept. Not so? So what's your y-intercept here? It's negative 5. So y is equal to 2x? Minus 5. Or you can write y is equal to 2x plus, in brackets, minus 5. And then remove the bracket. Yes, Michael? The gradient. Remember, there's a note we made. We said if lines are parallel, gradients are equal. If lines are perpendicular, that means you say the gradient 1 times gradient 2 is equal to minus 1. If you weren't here for that lesson, please write that down. Gradient 1 is equal to the gradient 2. It's very important to note at this point. And this comes up over and over and over again. So master it now. Because later on this question is going to come in again and again and again. Okay, lines are parallel, gradients are equal. If lines are perpendicular, that means you say when I multiply the two gradients, I get an answer of negative 1. Okay, you are strolling, you're taking your own time. Doesn't look like you want to be here, no? Now why don't you sanitize? People, you guys okay with this? Any confusion? Right. Okay, we'll do another one. I know you guys are very excited about this maths. Huh? Like you were very excited about the geometry. You remember when we started out, you said how much you love geometry and geometry is my friend. And but tell you what was different? Now, that time you people used to work. You never worked then also. And you were good in geometry. But now, you can be again that girl. You can go watch all that videos. Every time you learn something, you like the video. No? Didn't you subscribe? Yeah, now when you watch a video and you learn something. If you don't learn anything, don't press it. However, if you learn something, you like. You like. Who like? You like? Who like? Okay. Right. I'm going to change the name Ubatin. No? Right. There isn't that place at the back. Right, here we go. Listen. Number 5. Determine the equation of the line parallel to y is equal to negative x plus 3, which passes through the point negative 1 and 5. So what we have, I'm going to sketch you what you should see. The lines are parallel. The lines are parallel, what do we know? Gradients are equal. The line 1 is equal to y is equal to minus x plus 3. The second line is parallel to it, but it's passing through negative 1 and 5. Okay, I'll give you an opportunity to do that. I'll pause the video at this point. Alright, people, remember these lines are parallel. If lines are parallel, gradients are equal. So the gradient of the first line is equal to the gradient of the second line, which is equal to negative 1. As you can see, the gradient is negative 1. You all got that? Yes, sir. So what do we now say? Y is equal to? mx plus c. mx plus c is? Y equals x plus Negative x.
So is that a negative?
Because listen, x is negative there. Negative 1.
And the 1 is like negative.
Yes, there's negative 1x plus c. Now what is c?
5.
Now what is c normally?
Y
is c. Now on your y-axis, if that cuts at 5, then that coordinate's going to be 0 and 5. Can you see that? So is this a y-intercept? No, that means the graph is just going through negative 1 and 5. Can you see that? So if we draw this graph, it's actually going through, 5 is not there, negative 1 and 5. Can you see that's what it's going to look like? So to calculate c, that c value, what we do is, we substitute negative 1 and 5. Like we did when we did the equations given 2 points, you remember? So then we make the same x and a y. So 5 is equal to negative 1 times negative 1 plus c. What's negative 1 times negative 1? Positive 1. You bring it over, becomes 5 minus 1 is equal to c. So c is 4. Y is equal to minus x plus 4. Okay? Little confusing, but okay. Weights, right? Sorry? You do understand? Okay, which part don't you understand? Okay, listen, I can't. Listen. Yes? Y is equal to x. But firstly, if lines are parallel, what do we know? The gradients are equal. Now, what was the gradient of the first line? Go back. What's the gradient of that first line? The first equation there, y is equal to minus x plus 3. So what was the gradient of that line? I'm asking a question. What's the gradient of the first line? No, I'm talking. Okay, just take you one step back. If you look here, there was a time. I just hope I didn't delete that. It should then, if this page is here, it should be here. You remember that? No, it was the exercise before this. When we started out, here, you remember here, this exercise. We said if y is equal to 3x minus 2, what is your m? Your gradient? 3. Your y-intercept? Minus 2. What's your gradient here? 4. Your y-intercept? 1. What's your gradient here? 3 over 4. What's your y-intercept? 0. There was a reason why. Yeah. Y is equal to negative x minus half. The gradient here is? Negative 1. Your y-intercept is negative 1. Can you see that? You remember that? Now, based on that exercise and that the examples we did, what is your gradient here? Negative 1. That is why we say the gradient 1 is equal to the gradient 2, which is equal to minus 1. Why? Because if lines are parallel, gradients are equal. That is why I got negative 1 as your m. You understand now? Right. Then, you're saying your y-intercept is 5. It will only be 5 if you got that, which is minus 1 is also 0. Like, if you draw this graph, and it goes through here, that is your y-intercept, not so. But if I must plot negative 1 and 5 on the Cartesian plane, then this will lie here. You see that negative 1 and 5 will lie there. You see x is negative 1, y is 5. So is that, if I draw a line through here, Is that your y-intercept? Is that your y-intercept? No. That is why that can't be 5. So what is C? C is your y-intercept. What's the coordinates on your y-intercept? X is? What is your x coordinate on your y-intercept? It will always be 0. X is 0 on your y-intercept. So this is not a y-intercept. This point here is not a y-intercept. This is the point the graph is just going through. You understand? That is why when I drew here, I drew it with that point being the graph going through that point. Okay, whereas in the previous question, we were told, find the equation of the line parallel to that with a y-intercept of negative 5. Can you see the difference? The y-intercept was given here. Here, no y-intercept is given. Right, let's look at the next one. Throw this quickly. Pause the video again at this point. Right, so this one we will be doing together. So we are told in number 6, 6.1, you must determine or find, what's it find, yes? The equation of AB. So, now this, as you can see here, all your steps come together now. Everything we've done thus far becomes one. Okay. So, to determine the equation of a straight line, what do I need? You need 2 points, or a gradient and a point, or a gradient and a y-intercept. Not so? Or we need an angle and a point. Not so? Who can remember if the angle is 45 degrees, then what's your gradient? 1. The gradient is 135 degrees. Okay. And if your gradient is 0, what does that mean? Yes, it's parallel to the which axis? X axis. Okay. So the question says the equation of AB. So if I look at line AB, what do I have on this? I have that point and I have that point. Not so? I have 2 points here. Go friend. Look here. Then, yeah, you. Jessica, that's a problem. You see, if you're sitting looking that way, then it looks like you're not looking at me. Then I feel so bad. Okay. So do we have 2 points on AB? Yes. What are the coordinates of this point? No, this point here. 0 and 3. Can you see that is y? That's also known as what? Your y-intercept. Can you see it? This point here is what? 1 and 0. And that's also your x-intercept. You guys understand? So let's look at 6.1. You got 0 and 3 and 1 and 0. So the equation of a straight line will be in the form of, what's the standard form of a straight line? Y equals mx plus c. Not so? So write that down. Y is equal to mx plus c. Alright, so y is equal to mx plus c. That's the standard form. How do we calculate m? The gradient is y2 minus y1 over x2 minus x1. So if I make that x1, y1, x2, y2. Not so. Do your substitution now. Okay. Yes, you're supposed to have substitute. So what do we get? 0 minus 3 over 1 minus 0, which is negative 3. You see the gradient is negative. What do you notice about this graph? It's decreasing. Can you see that? So what's your equation now? Y equals negative 3x plus c. But c is what? What is c? C is your y-intercept. Do we have a y-intercept on this graph? Yes. What's the value of your y-intercept? 3. So it's going to be plus 3. Now say for argument's sake, we don't have a y-intercept. Then I would have said plus c and then substitute a point on here. Say it's the 1 and 0. There's the x and the y. So 0 is equal to negative 3 times 1 plus c. This is negative 3, bring it over, becomes positive 3. Can you see that? It gives you the same answer. You will understand. You can only substitute the value for c straight if the y-intercept is given. That's the only way. The y-intercept is not given, I can't do a straight substitution. Does it make sense? So I'm going to write here the equation is y is equal to negative 3x plus 3.